Let's now look at this problem in a spreadsheet, which really simplifies the calculations quite a bit, and it gets simpler in later weeks. Here's the basic data, and if you would add these up, you get 16 for both of them, both projects, but the cash flow that comes to the company, they put down $4 million in 2011, and then they get these returns over the next years, and the net result of that, if you just add them, is 16. But that ignores the time value of money. This here $4 4 years from now is worth as much today in 2011. So what is it worth? Well, we're going to find out. So here's the first line, Project A, 4, minus 4, 7, 4, 5, and 4. 2011 is the present year, which is a year old. And so, since it's the present, it's still $4. It doesn't have any, it's present time. It doesn't have to be discounted. There's no discounting to do. In 2012, we want to discount the 7 for 1 year. So we take the equal, that value, 7, which is in C9, and divide it by 1 plus the rate. The rate is in right up here in B6. I'm going to put $B$6 so I can copy that without it changing. And we got to raise that really to the first power, 1th power, if you use such a word. I can't, there it is. Because we're going to discount it 1 year. And it's $6.36. $7 a year from now is worth $6.36 today. We have to do the same thing for the $4, 4 million actually, these are all in millions, 2013. I'm going to just drag this one over. It says 364, well, it's not quite right. D9, for now it changed the C9 to D9, which is correct, and B6 stays the same, but now it's 2 years. So we put 2 up here. But just changing one number is a lot easier than changing all. Now it's 331. So $4 of 2 years from now is worth 331 today. And do the same thing with the next two. Put this and drag it over the next two. Change this to 3 years. Change this to 4 years. Go back 1, 2, 3, 4 years. So 4 million in 2015, 4 years from now, is only worth 2.73 million today, if our rate that we evaluate projects is 10%. And this is the kind of stuff we're going to be looking at starting in about week 4, 5, and then the rest of the semester. We're particularly looking at these with uneven cash flows. But if you didn't, since these are all discounted to the present period, they can be summed. This 16 should not be summed because this $10 is not equal to $10 there. They're different, like adding apples and oranges. Now we can sum. And so this cash flow of 4 or 5 years, including the present year, is $12,160,000. The term we use is equivalent. This 12.16 million is equivalent to this cash flow. This one number is equivalent to those 5, basically. We can do the same thing with Project B. Discount each one. These show the numbers here. Use numbers instead of addresses. We sum those as 10.04. So when you look at this equivalent value, it's less than this one, so this is probably the project that we would choose if we were choosing between these two. It has a higher value. It's worth more. You might say, why is that? Well, it has a high value here in the first year, which doesn't just discount it much, and the lowest value is 4, which in one of the 4s is 4 years, so that doesn't cost as much when that's discounted. Here you have 10 in the last year. That's a big one, and that gets discounted 4 years. It goes all the way down to 6.83. So the timing makes a big difference on what you get out of a project. Another thing we could do would be to take this here $12.16 and say, what is that worth 4 years later? Find the future value. You take B11, you multiply by 1 plus 10% to the fourth, it comes 1780. So that is the equivalent future value to this present value and to this here stream of cash flows. I had the wrong one. This stream of cash flows, this equivalent value is A. B, 10.104 will be worth $14,700,000 in 4 years. That's equivalent future values, equivalent present values, and equivalent cash flow streams.